Hello, this is a video that describes the circular reference resolution in solar model, example solar model. I'll go through a very brief explanation of why functions rather than copy and paste macros or goal seeks or solver methods are so much better than the alternatives. I want to show you a little bit about a very comprehensive function that can resolve the circular reference macro. Resolve the circular reference. It shouldn't say macro. It should say problem exactly. Solve the circular reference problem. Okay, that's good enough. No, it got all flustered. Okay, and then I'm also going to give you an overview of the whole function, and I'll show you how tests of the function are made, and we'll go through a little bit of documentation. Really just going to show you the function mainly. So I'm going to the solver, the solar model. If you want to find that, if you have the Dropbox, the solar model, you can go to chapter 1, folder number 2, project finance examples. Under project and finance examples, you go to the solar model. Now, in the solar model, if I change the DSCR, change it from gearing to oh my. Okay, change the gearing assumption, change the DSCR assumption, change the repayment style assumption, change the drawdown assumption, change the debt tenor, change the we could have changed the capitalized interest assumption, change all of these, and then make a different whole case. Everything works. No goal seeks, no copy and paste macros. You can imagine to solve this, to do this with a copy and paste macro, you have to have all different buttons, or all these buttons would be associated with multiple different copy and paste, or maybe one big copy and paste. It would clunk through it. If I wanted to make a goal seek, which I showed you in the other video, let's say we want to see we have an equity IRR of 8%. We want to see what the O&M expenses have to be in order to get that up to 10%. We could do a data what if analysis. He's playing some video games on how embarrassing. If we want to make this equal to 10%, oh god, yeah, by changing the O&M costs, we can just see what would be necessary, which is kind of an unreasonable assumption. But oops, you can do all of these. I'm going to put this back to 18. You can do all of this kind of analysis because there is a circular reference function. Now, to use this circular reference function, here's the problem. Everything is in this case, it's a function that gives 3 different outputs: the size of the debt, the total adders, which the total adders are the things that are affected by interest, including interest during construction, fees, and the debt service reserve account. This column has the amount that's computed in the model. This column has the amount that's computed for the function. This column says, well, if in our structuring mode, then we're going to use the function. Otherwise, we're going to fix what's in the function. You remember, if the fixing of the debt just does a little copy and paste, now these are precisely the same as they are in the function. Now the way a function works is like a sum function or anything else. Now it looks horrible. Look at this. It looks horrible. Like, this is so long and tedious. What you can do with a function, this is a function that's an array function, so you have to shade the area and clip it. Now what I've had to do is, for each, there's a little description. This function computes the debt service, whatever, the debt level, IDC, and so forth. It says an on-off switch. If we change that to false, true, it turns it off. The construction array, that comes from the working analysis. That's the true-false switch. A repayment array. If we look at the repayment array, whoops. Oh no, just a minute. How do we get down there? Then it tells you what it is. So we put in all the requirements: the EBITDA, the construction, the tax rate, the gearing flag. By the way, these things have to be abbreviated. There's a horrible problem in Excel that limits the number of characters you can read into a function. That's why these things don't have very descriptive names. But you can see all of the types of things you have to enter, which it looks like a lot, but you just have to work through them. And then these ones that are a little bit lighter are the abbreviated functions. Now I'm going to tell you now, and I'm going to tell you again and again in another page. If you want to apply some of this, what I would suggest doing is working through a simple example. Once you work through a simple example, do you see how it really works? You can then try to apply some of this. You can try this function or try to write your own. Now I'm going to show you the functions right now, and the functions look a little bit intimidating, but I hope you don't, I hope you see that it's worth the work. If you make one single function in these models, once you make the function, you can apply them to any of your models. You can just copy the whole function across. So if you go to the developer and the macros, and we go to this workbook, I put this into a debt function. All right, and for each, the debt function, the first thing is there's this thing that describes the debt function. That's what puts those little descriptions in. We need to read in all of the variables that are going to be used. That's the problem. We have to redo all of the calculations, essentially. And then if we have some optional variables, if they're missing, if they're not entered, we have to assign them. The first thing we need to do is assign when the start periods are and the end periods for the repayment and the construction are. I need to assign a couple of other things. And then we go through, and if the gearing flag is false, which means we're going to size the debt from the DSCR, then we're going to define the debt commitment depending on its level debt. If it's a level debt assumption, that says select case. If it's the repayment code, you can use a level repayment annuity or a sculpting repayment. Now this one just seeds the analysis. And then we have to compute the DSCR. And then here's the key to the whole thing. We make an iteration. We go, this thing, it goes around for a maximum of 40 times. You never need to go that long. But it says, look, if the gearing flag is false again, then we're going to define the commitment. If the gearing flag is true, then the commitment is just the total cost. The debt commitment is the total cost, which is the plant cost plus the fees plus the DSRA plus the IDC multiplied by the debt ratio. And then we need to recompute the DSRA. This is all part of the circularity, and you go around and around and compute it. And where is the end of the, do you see the next iteration? That's the end of the whole process. and it goes around until that difference is very small. And if we had one iteration where we computed the adders, the total fees and IDC, if that doesn't change anymore, then we say, okay, let's stop the whole loop and compute the compute the function. And then each of these separate, you can see each, the level debt and the annuity debt and the sculpted debt, that's all, these are all separate functions that are called. I think the first function I showed here, one of the first major function, is the construction funding function, which is essentially goes through, okay, we compute the upfront fees, we compute the DSRA, we compute the draws, and I put a little test, a debug test, and then we do the sculpting, and after we do the sculpting, we do the level repayments, and then the annuity repayments. So you can walk through and see how all of these calculations are made. I know it seems like a very big pain, but I insist that the pain is worth it. And this is a very, very comprehensive example. If you're just only solving for if you only have one method, if I didn't put a different possible repayment method, a different possible funding method, a different possible gearing or DSCR method, different possible debt tenors, the whole process would, different possible lengths of the DSRA, the whole process would be much, much easier. But by putting all of these in, we have a very comprehensive example, and I would encourage you to look at the page that illustrates how to compute the circular reference in simple examples to really understand how this all works. By the way, there's a little bit of a circular reference on the refinancing, because when we change the refinancing, that has a tax circularity associated with it. And then also, if you look at, I'm going to look at this in Word, but if you look at my book, there's a whole big chapter that works through issues, eliminate dreadful circular references arising from sculpting, funding, and DSRA in project finance models, and it works through step by step how to resolve those functions. And the other thing is, oops, I don't have it open. I just had it open. There is a exercise that is on the disk that works through very, very simple examples of how to go through step by step and resolve all the circular references. And that's the end of this